Hello and a warm welcome to this RTI Group webinar. I'm Michael Olding, Head of Solutions at RTI Group. And in this webinar today, we're going to be looking at the RTI Mako meter, the latest and greatest X-ray tool on the market. And we're going to be looking at X-ray testing for all diagnostic X-ray modalities. So a bit of housekeeping. If you have any questions during the webinar, please feel free to use the chat function with the icon shown on the left-hand side. And our colleague Steve Holmes, VP Sales North America, will be available throughout the session to answer your questions. But we will also invite questions at the end of the session. So if you have any questions at the end, we will take them there as well. Okay, so we're going to look at the RTI Mako meter across typical examples of diagnostic X-ray applications and the challenges we face. So let's start by looking at radiography. So for example, your typical X-ray room in a hospital. We're also going to look at fluoroscopy, so looking at pulsed radiation in interventional systems. We'll take a look at mammography, where we look at imaging of the breast tissue and breast cancer screening. Then perhaps consider the most complex. We're going to look at computed tomography, or CT, and how we do testing in that environment. And finally, we'll look at RTI Mako in X-ray dental applications. So for those who are new to testing, just a short background to the goal of testing in diagnostic X-ray. And that will be for consistent and reproducible image quality. So the RTI Mako system will be used to perform the foundational measurements to support accurate diagnosis of patients, but also, of course, and importantly, minimizing radiation to both patients and staff. So ensuring that our X-ray systems are working as they should be. Typical reasons for QA, of course, to follow industry and national standards. So it's a legal requirement globally when working with ionizing radiation with patients to perform QA procedures. We can also use it for preventative maintenance, so predicting failures and maximizing the uptime of our X-ray systems. And manufacturers validating the output of the systems in production through to acceptance testing on site, and then the lifetime testing throughout the use of the system. So we're going to overview a very simple typical procedure for those unfamiliar with X-ray testing. First and foremost, we place the active area of the meter in the X-ray beam. Then we'll typically head to the control room where we make the X-ray exposure either with a plunger or some sort of paddle or button system. And here we'll set and configure the X-ray settings on the system. And then we get our measurement results, the display of our data. And typical values we talk about are kV, dose rate, half value layer, HVL, total filtration, and information about the pulses if they're present. And finally, we have to follow our QA protocol, whether that's quick routine tests or more in-depth preventative maintenance protocols. And we can do that either by exporting data to a third-party software such as Excel, or with RTI Group products using our QA software known as OceanNext software, where we can produce traceable reports with information about the probes used, their calibration, the system that was tested on, and automated analysis, pass-fail values to produce that traceable report. So a little bit of background about the RTI Mako system itself. It is the newest and most modern X-ray meter on the market. So it's launched in 2024, and the first real launch of a product in this market really in the last decade or more. So it's the latest on the market, also the most accurate, the most efficient, and has the broadest application range. And in this webinar, we'll look at the reasons for that across the entire range of modalities. But of course, this is not RTI Group's first X-ray test tool. RTI Group actually produced the very first non-invasive X-ray multimeter in 1982. And after 40 years of experience and many generations of X-ray tools, we have landed at the RTI Mako which stands alone as the most accurate meter in the industry, with a KV uncertainty of plus 1.5% under reference conditions. It has a modular, future-proof design. We'll see the advantage of that in all the different applications that we have to test in. And the best ever efficiency. Whether we're performing complex routines and we can automate our protocol with the Ocean software, or now with the launch of the new Mako Display app, which we'll focus on in this webinar, it's faster, more accurate, and more efficient than ever to perform your X-ray testing. And finally, the broadest application range. You can connect a fleet of probes to the Mako system, whether that's ion chambers, probes for MA and MAS measurement, DAP chambers, dose probes, or light meters, and a range of others. So after its launch in 2024, RTI Group then launched the new Mako display in 2025, the very first app wireless display of its kind, utilizing the high-power Bluetooth, which is installed within the Mako base unit, which gives you fast, instant wireless data straight from the Mako system to the display. So it's designed for ultimate usability, to be intuitive, and to get that instant data out of your Mako system. And that's what we will primarily focus on in this webinar today, using the display to utilize all the strengths of the Mako system. But of course, we have a broad range of software capabilities as well, whether you want a simple display on your phone device, which you can download for free on your personal phone or have the display within the kit, through to software on tablet, all the way through to the Windows PC as well. And here we have our OceanX software, which, as we discussed, can produce automated routines, automated analysis, take out all the manual work in your QA protocols, and produce those traceable reports, which can be customized to any kind of format. An example here showing customized for US State Inspector reporting capabilities. So now we'll look at the testing challenges across the different modalities. And we'll start with radiography, perhaps the simplest place to start, where we have our typical X-ray system with the X-ray tube at the top, and we have our X-ray detector underneath, and the patient lies in between, and we can image the torso or the abdomen or any part of the body. Or a vertical mounted system, for example, when we take chest X-rays. And there are a whole range of RAD systems that we'll come across within the market. Another example here being a mobile system, where we can place the detector behind the patient, for example, in an emergency department, and more flexible positioning of the RAD tube. So in these environments, we're going to utilize the Mako RF probe. RF standing for radiography and fluoroscopy, but it also covers CT and dental applications, which we'll see. So in radiography, as we say, might be the simplest form of X-ray, in the fact that we have typical single-shot images in the range of 5 to 100 milliseconds. So the RF probe covers the entire range up to 155 kV, has the highest accuracy on the market. And a great thing about it is the simplicity. It's orientation independent. You can place the RF probe in any orientation in the X-ray beam and get an accurate reading. You don't need to place it in any specific position. And together with the Mako display, we have no selections required to measure. Again, fully wirelessly in the control room, we get the data. Fast, wireless, instantly. It has an autosave function, so we don't need to manually save anything. It'll always keep measurements in our current session or in the logs behind the menu in the history. And we also have the capability to export the data directly from our current or historical measurements. And so here we'll typically measure dose, dose rate, KV, time, HVL, total filtration, and also information about the pulses. But of course, in RAD, we typically only have the one single pulse or exposure. And the green dots indicate the presence of a waveform, which we'll look at in the next slide. So now we'll move over to fluoroscopy, also termed interventional systems, which are typically used in the surgery room. And here we're posed different challenges, whereas in radiography, we talk about single shot images. Here we talk about pulsed radiation. So in a surgical theatre or in this environment, The typical duration of the X-rays in total may be longer when we're doing the procedure, such as catheter insertion. So rather than keeping the radiation on constantly, the radiation is pulsed. So we get low dose pulses, but the total exposure time is more. So we need a probe that can handle that, and that's exactly what the RF probe has been designed to do. Handle the highest dose rates all the way to the lowest dose rates and the short pulse lengths or pulse widths that we see in these applications. So again, typically pulsed information can be very shorter pulses than we see in RAD, and the Mako RF probe has been designed to handle that without requiring any selections. The probe has also been designed to be more flexible in the setup so that you can connect the lightweight probe to the base unit via a cable. So typically in fluoro systems in surgery, the detector may be above the patient and the tube underneath. So this allows easier positioning of the Mako probe. It's lightweight. You can connect it to a detector surface or in different environments where we need a bit more flexible positioning. The design of the probe has also been optimized for what we call automated exposure control or brightness control. And that means that the systems themselves will automatically detect the density within the image, and they will adjust the settings or the dose output based on the density that is seen within the image. So we don't want something very dense in the image when we're doing our testing. So the Mako probe, as you can see, a radiograph of it here, the active area is very low density, and then we have an almost invisible gap to the electronics, meaning that when we're testing in these conditions, we can place the active area of the probe within the field of view, within the X-ray beam, and all the electronics and other parts of the system can be outside of the field of view, meaning we have minimal impact on the AEC. Therefore, consistent, reliable results. With the Mako display, again, makes it easier than ever to get your test data out. No selections required to measure, fast and instant. We get similar parameters as we see in radiography, dose, dose rate, kV, but then we also automatically detect the number of pulses in this exposure. We also see the pulses per second based on the total exposure time, and importantly, the dose per pulse. So we need to be able to verify that the machine is doing exactly what we expect it to within these pulses and across the entire exposure. So if we wanted to see the waveform of this exposure, we simply select the dose or the dose rate value, which will enlarge, and then we'll see the waveform. So we simply click again, we'll go into landscape view in the display, and here we can see a representation of the entire waveform of the exposure. So then we can do some simple qualitative assessments here. We can zoom in, see the pulses a bit more, zoom in even further to a single pulse. And Mako has the sensitivity and the resolution within the waveforms to be able to detect these very short pulse widths and pulse lengths, and even handle those very low dose rates that we typically see in fluoro. So that's how Mako has been designed intelligently to handle both RAD and fluoro applications. But here we might also want to test the generator as well as the tube. So the generator, of course, supplies the power to the X-ray tube, both the voltage and the current. So we sometimes need to check that the output of the generator is doing as we expect as well. So here we can utilize the Mako MAS module, which can measure with a probe both the MA and the MAS. And here's a typical setup where we have the Mako base unit with the RF probe in the primary beam. We then connect via cable the MAS module, which then connects to the MA probe. Here we have the Mako, what we call invasive MA cable. And this connects into the MA or MAS port on the generator. So we can generate simultaneous data from one exposure from both the primary beam and the generator. If you can't access the ports on that generator, or you have different applications where that's not feasible, you can also connect a similar but different cable connected to our MAS2, which is our non-invasive MAS probe. And this clamps on to the high tension cable on the cathode side of the X-ray tube so that we can measure the current through the high tension cable. And with the Mako display, we get all the values that we saw before from the RF probe. But as you can see now, we also generate the MA and MAS values from the generator. So again, we can simultaneous measurement with one exposure all through the simple display. Now we're going to turn our attention to mammography, which is a slightly different application, has a different challenge. And in these systems, whereas rad and fluoro, we'd be looking at multiple tissues and bones and denser objects. Here, we're optimized for soft tissue because we're just looking at breast imaging. So typically for a mammogram, the breast is placed on the detector plate. We have a compression paddle which holds it in place. And then the X-ray tube at the top, we take an image with the X-ray detector underneath. And for these applications, we use our dedicated Mako Mammo probe. And so with rad and fluoro, we might be looking at higher kV ranges, 70, 100, and in CT up to 120, 140. Here we're talking a much lower kV range. So a typical mammogram is in the 20 to 39 kV range because we're optimized for that soft tissue. And another typical application, which is fairly ubiquitous within systems on the market now, is contrast enhanced modes, which is in the 40 to 49 kV range. So the reason for that higher range is the patient is infused with a contrast agent, such as iodine, which gets taken up by the cancerous tissue more readily and therefore provides more contrast in the images. So therefore, we have to have a test tool that can cover both of the ranges. And also the third typical scan type we see is 3D scans. So where the tube moves slightly from right to left and takes angular images so that you get some 3D depth perception in the image as well. And mammography, in order to optimize the image quality and contrast in soft tissue, manufacturers use a range of different what we call beam qualities, which is the target and filter material combinations used to produce the X-rays. So in rad, that will typically be tungsten aluminum, but as you can see by the table, three typical target materials are tungsten, molybdenum, and rhodium, together with a range of filters and filter thicknesses such as aluminum, rhodium, silver, copper, titanium, and molybdenum. And so Mako covers the widest range of these target filter combinations and also filter thicknesses, covering both older systems and the latest X-ray mammography systems on the market. And unlike other sensors on the market, which are limited to 40 kV, which means you have to switch probe when you do contrast enhanced mammo to an RF or a separate probe, the Mako Mammo covers the entire range all the way up to 49 kV. So one probe for the entire range of measurements with the highest accuracy, and it has the same orientation independent principle, which means it's insensitive to the Heal effect. You can place it in any orientation in the field of view and get an accurate data without any position check. And it also has the widest angular measurement range. So it was designed perfect for tomosynthesis measurements, where we can measure plus minus 30 degrees for dose measurements. So we can compare the dose in a 2D shot, also in the tomosynthesis or 3D mode. So we can check the dose in both modes, which is very important and is unique for the Mako probe. A Mako display, similar, very easy to use. There are no selections required to measure. So you can go up to any mammography system on the market and you can measure dose, dose rate, time, and HVL without any selections. Also unique in the market, other sensors will force a selection of is the compression paddle in the beam or is it not in the beam? Whereas Mako, you don't need to make that selection. It automatically detects and will give you an accurate reading. To measure kV though, like with any sensor, needs to be calibrated for that beam quality. And as we discussed, Mako has the widest beam quality support. So to measure kV in mammography, you simply select your beam quality, such as tungsten aluminum shown here, and you will also get your kV value for that beam quality. So that simplifies a lot of processes in mammography. And so now we'll take a little look at computed tomography, or CT. And this can be the most complex, throws a lot of challenges for testing, because rather than a static tube and a static detector, here we have sort of the donut-shaped system. The tube and detector will be opposite each other. They rotate around the system very fast as the patient is moved through during a scan. So here we need phantom and also different sensors, such as the RTI CT ion chamber and also the patented RTI CT dose profiler. for CT. So we typically can measure KV on the systems, but a big part of testing is measuring what we call the CT dose index, or the CTDI. And we can measure this by connecting the ion chamber module and the legacy module to the CT ion chamber and the CT dose profiler, respectively. So that modular design of Mako allows you to connect the right probes at the right time. So we have a very accurate CT ion chamber, which is traceable to primary standards. Typically, we see it in the 100mm length. And when measuring KV in CT, it's very similar to a RAD system. So we place the RF probe either at the bottom of the gantry or use the patient bed to place the RF probe into the center of the beam, keep the tube in a static position and take an X-ray shot. It'll handle the higher KV ranges in CT. But then for CT dose index, we introduce the CTDI Phantom, which RTI also supply, which houses your standard CT ion chamber. And this is made of PMMA and is used to perform the CT dose index tests. And so when measuring in CT, what a physicist may be interested in is understanding the dose to patients. But Mako and these tools will provide the foundational dose measurements and performance of the system, which help to calculate those later on. So typical measurements that we discuss, or you'll see, is firstly the CTDI 100. And that's essentially the linear dose distribution across a 100mm pencil ionization chamber, scanned in the center of the CT system to give us a single CTDI value. Then we can come across the weighted CTDI, which we get by scanning the ion chamber in the center position and in 4 positions in the periphery. And we calculate the weighted CTDI by 1/3 of the center scan by 2/3 of the average of the peripheral, which more closely matches what we'd see as more of a human dose profile by performing these tests. And you can do those 5 scans with the CT ion chamber to calculate the weighted CTDI, or you can use the CT dose profiler. So unlike the CT ion chamber, the dose profiler, it has the same form factor, it fits into the Phantom. This is actually a solid state point dose detector. So again, unique in the market, and you can get all of that data plus more, such as the beam width, with one single helical scan of the dose profiler through the beam. And then the CTDI vol, which you'll typically see on the X-ray system, calculated by the X-ray system itself, will essentially be the weighted CTDI divided by a pitch factor. And finally, what's known as the dose length product, which takes the CTDI vol and multiplies it by the scan range. So there's some of the foundational measurements that we perform in CT. So we can use the display again together with, for example, the CT ion chamber, where we'll get the dose length, the dose, and the time values. And we also have, for example, a pause feature. So if you've ever used an ion chamber, you'll know that when you move it around, it can easily self-trigger and trigger a measurement that you don't want. So when you're moving that ion chamber into the correct position, you can just pause the measurement until you're ready to take the right measurement and have a cleaner data set. We won't go into this webinar, but using the Ocean software together with these tools can completely automate and streamline your workflows in CT, meaning you don't have to do any manual analysis. So the final application we'll look at is Mako in dental X-ray. And here there are 2 typical applications that we see. We have intraoral dental X-ray, in which the X-ray tube is on one side and the detector is placed within the mouth, but the other side of the tooth to take an X-ray image intraorally within the mouth. Or we have extraoral dental systems, such as what we call the panoramic dental systems. And in these, the X-ray tube and detector are rotated around the patient, and then we provide sort of a panoramic view of the mouth and below the gum line. So you get a single view of all the teeth in a panoramic image. And here we can use, as we discussed earlier, the RF probe, which covers the entire range, RF, CT, and dental. But if you're only in the dental space, you can also have the dental probe, which is limited to 125 kV, which will typically cover all dental applications. They have the same accuracy and form factor and detector design, so you'll get the same accuracy. And for intraoral applications, again, it's similar to RAD, where we place the RF probe or the dental probe under the X-ray intraoral tube, make a shot, and we'll see the data in the display. But one of the trickiest setups in dental is these panoramic systems, because they have very narrow X-ray beams. And we have to set up the probe in the center of the detector area. So that's where we have the panoramic dental holder for Mako, which allows you to place the probe in the correct position. You can place the base unit around the back within the strap, so you don't have cables as the system is rotating around, and also allows fine adjustment of the probe left and right. And if we were to make an exposure, we would see, similar to RNF, all the values that we would expect with dose, dose rate, kV time, HVL and total filtration, and any pulses. But one unique feature which has been designed in the Mako system is what we call the unique position guide. So in the center of the Mako probe is a sensor that is less than 1 millimeter diameter. And that means that we can measure very narrow X-ray beams, which are typically in the millimeter range. And if this isn't fully irradiated, the field error will actually prompt the user to move the probe into the correct position, either right, left, up, or down. So it ensures that the center of the detector is fully irradiated, which again is unique in the market, allows you to optimize the position. Because if the X-ray beam doesn't cover the full detector, then we might underestimate the dose. So we need to ensure that the center of the detector, even if you get a value with other sensors, you need to ensure the central detector is fully irradiated. And that's what Mako allows you to do for optimal positioning and trustworthy results. So to summarize, Mako has been designed for simplicity, the intelligent design with all the 40 years of experience and unmatched accuracy across all the diagnostic X-ray modalities that we've seen. It's wireless as standard, Bluetooth is built in, it's lightning fast, it penetrates through lead walls or lead shielding that we'll typically have in these environments, so we have no issues being in the control room. The great thing about the Mako and the display is no selections required to measure. The intelligent design takes the complexity away from the user, streamlines, makes it more robust and obviously accurate. It has full auto ranging, so there's no need to tell the probe whether it's high or low dose rates or set different settings. It will detect it automatically to again take the use or the manual work away from the user. The lightweight probes allow connection either in fluoro or in dental applications so that we can place the probe when it comes to tricky positioning. And again, the orientation independent nature across the RF and Mammo probes is a fantastic plus and means that we have robust data whoever sets up the probe, so we don't have setup errors and differences between users. And again, together with the display, it auto adapts, no settings are required. It's been designed for ultimate usability and to be intuitive, and you always have the Ocean software there when you need to do more complex tasks. So to summarize, Mako is the most accurate, most modern, the most efficient, and has the broadest application range of any X-ray tool on the market. So thank you very much for listening. If you have any questions, I will now hand over to my colleague Steve, and Steve can either take any questions within that's already in the chat, or please add your questions now and we can answer them.
Thank you, Michael. I've actually answered or responded to a few questions in the chat. Interestingly, there are a few questions about the mass probe options, whether it's a physicist or an engineer. I think a couple people noticed the clamp-on or non-invasive mass 2, which obviously could be used by anybody in a facility without having to remove the covers and easily get their measurements in terms of mass. Waiting to see if there might be a couple other questions here. Is the well, let's see, it disappeared. Let's see, no longer available. I think somebody asked a question about calibrations, then it disappeared, but we of course operate on our OEM recommended 2-year calibration cycle. We of course have our USA lab in New Jersey, and the turnaround time on those systems is 8 to 10 days, so extremely fast. And of course, our lab in New Jersey, as well as Justin Hines, is available there for support as well. So one of our primary goals is not only just to get these systems in your hands and start testing, also to train and onboard you so you could utilize the system as most efficiently as possible. I think most people want to move to this modern platform, a lot of different options in terms of the workflow that you need to use, whether it's a simple application or it's a full PM. So let me see if there's any more questions that have come in, and we have a little bit of time here. Battery life per session. We said the Mako has actually a battery life approximately 20 hours. So I think the product was 15, so we've increased the battery life, and that is while using Bluetooth as well. The Bluetooth module is built in within the system. You don't have to purchase an extended dongle to attach to it. Everything is built within the system. I'm just checking the thread again to see if there's anything there. It's one of our first times using this platform, so I'm not sure why it says questions no longer available. I know that we'll receive more questions potentially over the next 2 hours through the webinar resource. So if you've submitted any questions or we haven't had time to answer those, please put your questions in the chat box where the question mark is at the top. We'll respond back to you. And a couple things just as maybe housekeeping. The Mako video will be available this webinar. And of course, what we'd like to do is make ourselves available, especially here in the US. We have our area sales managers throughout the country. Justin Hines, based in Austin, Texas, is our product specialist. Our office in New Jersey. We're here to join a Teams call, or of course, if you invite us to your site, we'll come out, demo. We have a lot of things available to you to make sure you have a thorough review of the tools that we have to offer, and then help you move forward. So, Michael, is there anything else that we should cover here before we wrap up?
Absolutely. I think you covered everything, Steve. Everyone will get a follow-up email. And again, if there's any questions that were there in the chat, we'll receive them within a couple of hours so we can get back to everyone with any questions and follow-up. But I think that was everything. Thank you, Steve.
Yep, thank you. I think you will sign off.
Thank you very much. Yep, I'll close the session, and now the video will play for those who want to stay and